All right, here we are with section 3.3, which is modeling with functions. So we're doing more of the real world stuff here. We're looking at some word problems, and we're going to see what is function notation and how can you use it. So we're going to look at two different vocab today, just independent and dependent variables. Independent variables are the input, what you're putting in. Dependent variables are the output, what you're pulling out. So the first thing we're going to do is we're just going to go through and identify those. What are the inputs? What are we putting in? And what are the outputs? So if we look at our first example says Jorge buys 6 pounds of gummy worms at the grocery store for $12. So we've got to kind of identify, all right, so let's picture we're Jorge right now. We're going to walk into a grocery store. We're going to buy some gummy worms and we're going to have to go pay $12. So we're thinking, what is the thing that's being put into the situation? So what is Jorge having to input to get some sort of output? So what is the decision Jorge is making? So what's the independent? Which is the input. Well, it's actually the pounds of gummy worms that he wants. Because that's going to really matter when he goes up to pay. If he only wants 1 pound of gummy worms, that's going to be a lot different of a price than if he wants 6 or 10 or more. So what he's inputting is his pounds of gummy worms. And what he's outputting, or what's the output of the process, is actually the money or the cost of the worms. Almost always you're going to see that the dependent variable in situations like this is the cost. You're putting something in, and the cost is what's the result of what you put in. Cool, let's look at our next example. If you ever still need this, you can just rewind or you can pause the video at any time. The next one says, the faster Tom walks, the quicker he gets home. So if we picture we're Tom and we're walking home, and we think, okay, well, what is going to determine, what's my input to figure out how fast I get home or how long it takes me? Well, his input is how fast he's walking. That's what he's inputting. If he walks super fast, he's going to get a much different output. He's going to get home quicker. Whether if he walks really slow and just relaxing on his walk home, he's going to get home a lot slower. So what comes out of how slow or how fast he's walking is how fast he gets home. So we're thinking about what is he having to put into the scenario situation and what's he getting out of it, what's coming out of it. All right, remember if you still need it, just pause it. Okay, the last example we're going to see for this, the cost of shipping a package is based on its weight. So if you go into UPS and you can just ship a package, they're going to charge you based on the weight. So if you do remember, what I did say is almost always the cost is going to be the dependent. But let's see. All right, so what are you putting into the situation? All right, well, you're putting in your package, and really it just matters what's your weight of that package. So that's the input. That's what's determining how much you pay. So weight of that package. And so your dependent is the money or the cost of shipping. Cool. So we're looking at what's the independent, what's the input, and what's coming out of the process. Okay, so what depends on the other thing? This one depends on the independent. So the cost of shipping depends on the weight of the package. So I'm going to erase this whole thing. And I'm going to give you guys some to work out. So remember, everything so far should have been on the right-hand side because I've been doing it with you. And now you're going to do these 3 examples on the left-hand side. These 3 examples, you're doing the exact same thing that we just did. You are identifying what is the independent and what is the dependent variable in these scenarios. Just in case you can't see them from your video, I'm going to read them to you. For A, it says, you and your friend go to the DVD store. Your friend buys 6 games for $25. The second one says, you order 6 sandwiches. How much does it cost? Third one says, if Harry sells 7 shirts, how much does he earn? Alright, so pause the video, complete this on the left-hand side. Cool. If you're back with me, I'm assuming you already completed that on the left-hand side, and we're going to go on to function notation. So we're going to go on to looking at the actual notation. I will say that this is the number one misused thing in math. So from IM1 to IM3, this is the number one misunderstood concept. So hopefully you take this home today, and it's a little bit challenging for people. People have a hard time understanding this. So if we look at this situation, Jose babysits for $8 per hour. So he charges $8 an hour when he babysits. Okay? So we're going to look and see, we're going to look at what we saw before. We had seen a table in our previous lesson of x and y's. Remember, x's are our inputs, so what's being our input, and our outputs. So the input for Jose is how, so I'll put independent variable, is how many hours. How many hours is he babysitting? The dependent is going to be the cost. How much does he make? Okay, so if he works 1 hour, he makes $8. Cool. If he works 2 hours, makes $16, right? 8 plus 8, 16. If he works 3 hours, he gets $24. 4 hours, 32. And so on. I could go on forever, as long as you think Jose is going to babysit for. Maybe y'all babysits for a whole day, 24 hours. So on and so forth. So here's a table to kind of represent some values. This is going to be very important when we get to actually looking at our function notation. But I want to see an equation first. So let's think our y values, which is how much is Jose going to make for babysitting, is going to equal $8 times the number of hours. So 8 times 1, right? 8 times 2 would give us 16. 8 times 3 would give us 24, and so on. So that's the equation we would use. But a lot of times we don't use this y. What we use is something that is f of x. And that means it's a function of x. It is, you put in an x and you get a value out. So it's saying, what happens when I put this x into my function? The 8x being your function. So let's look at some examples of what function notation actually means and how we see it. So the f of x is where people really start getting confused. Like, why are they not just using the y? Why do we have to use this weird f of x? So we're going to look at some examples for this chart here. Okay? If I ask you for the value of f of 1, it is saying, what is the y value? What is the y value when x is 1? Right? Because remember, this is f of x. Okay? It is the y value when x is 1 is 8. Alright. F of 2 is saying, what is the y value when x is 2? It's 16. Okay? F of 4. What is the y value when x is 4? It's 32. Right? I'm going to try one that's a little bit harder. So what is the y value when x is 100? So if we take 100 and we plug it into our function, what do we get for y? What do we get as the output? So if he works 100 hours at $8 per hour, you're going to get paid $800. So how did I get that? 8 times 100. Right? Because f of x is equal to 8x, and our x is 100. So this is equal to $800. I don't know if Jose's ever going to babysit 100 hours, but he would make $800 if he did. Cool. Alright, so that's function notation. So I want you guys to go through this exact same process, but with something a little bit different. I want you, yeah, actually I don't. We're gonna go on. We got a lot to cover. That would be through this quicker. So we're gonna start looking more in depth at function notation. So on page 129, you are gonna put the question under number B on the right hand side, and you are gonna put number 4 on the left hand side. So go ahead and get those cut out of your workbook and glued in. And this is number 4, by the way. I know here, I can't shade it. There you go, number 4. All right, and get it glued into your workbook. We're gonna be working on letter B on the right hand side. Okay, so for ours, it says, yours, make sure you printed the right, cut the right thing out. It should say the admission fee at a carnival is $9. Each ride costs $1.75. How much does it cost to go on 12 rides? Okay, so let's make a table real quick, because I like our tables. X, Y tables. So X is our input. Our input is going to be the number of rides, because that matters for our cost. So if we go on 0 rides, let's say we just go to the fair, we're not even going to go on any rides, we just go. It costs us $9 just to get in. Okay? But if we decide, okay, well, we're going to go on 1 ride, let's have fun. It's going to be $10.75. How did I get that? $9 to get in, plus $1.75 for a ride. 2 rides, okay? $9 to get in, $1.75 for each ride. $12.50. And we keep going up from there. $14.25. Okay? And you keep going up and up and up until you get to 12 rides. That's one way to do it. But let's try to set up an equation. Let's try and think, okay, well, our cost, Y, is going to equal to admission. So how much does it cost to get in? Plus rides. Well, that's true. Okay. So our admission is $9. Plus our rides, well, we don't really know how much our rides is, except it does tell us we want to go on 12 rides. So let's try that. 12 rides times $1.75 each. So you have to multiply those. As we saw down here, if we want to expand those, it would be 9 plus 1 times 175. 9 plus 2 times 175. 9 plus 3 times 175. And so on. So to figure out how much does it cost him to go on this many rides, we plugged a 12 in for our number of rides. So we plugged a 12 in, which means we're looking at f of 12, and we would get this equation, this expression, which when we solve it out, we get $30. Which means that f of 12, the output, which is the cost, for 12 rides is $30. $30 to ride 12 rides. Cool. So that's looking at modeling using a function notation. So I want you guys to complete number 4 that you had already glued in the left-hand side. I want you guys to complete number 4 just like we did this one here. Alright, if you're back with me, I am assuming that you have already completed number 4 from page 129 on the left-hand side. If you haven't done that, please pause the video and do that now. Alright, the very last thing we're going to do, so since you guys have already done this, we have 2 more things to cut out of the worksheet. This is from page 130. You are going to be cutting out letter B, which is going to go on your right-hand side, and you're going to be cutting out number 5 and number 6, and you're going to be putting those on your left-hand side. So get those cut out, get those glued in, and then come on back with me. Alright, for number B, just to make sure you have the right thing cut out and put in your journal, here's exactly what it should say. it should say a telephone company charges 25 cents per minute for the first 5 minutes of a call, plus a 45-cent connection fee per call. Write a function for the total cost in dollars of making a call. So let's think about independent and dependent first. Let's think about what's going into the call and what's coming out. Alright, well, we're inputting a certain number of minutes. Sometimes you have a phone call for 1 minute, 2 minutes, 3 minutes, 20 minutes, an hour. So number of minutes is what you're putting in. What's coming out, the dependent, is the value of the call or the cost, which is typically our dependent, as we've seen before. So let's write out an equation here, and then we'll figure out a reasonable domain and range. So our equation is going to be y is equal to the cost of the call. Just in general, to make a call, there's a cost, plus the cost of the minutes. There's a certain call dependent on how many minutes you make. Minutes you have your phone call for. Alright, well, the cost of the call, it tells us right here, it's just 45 cents just to even connect. So even if you don't talk at all, it's just 45 cents to connect. But for the cost of the minutes, it tells us it's 25 cents per minute. Anytime it says per minute, that means you're going to be multiplying. So 25 cents per minute. And minute, we're just going to call that x, because x is always our independent variable. Since the number of minutes was our independent variable, that's x. Okay, and we're going to rewrite this as f of x, because we always rewrite our y as f of x. That's function notation. And we're just going to rewrite our equation down here. So there's a couple things we need to understand about our equation. There's only specific values of x that can go in there. So what we call that is we call that our domain. Specific values of x that can go into our function. That's our domain. Right? And then we also will have a range. Our range is specific y values that we can get out of our function. Basically, how much can a phone call really cost? So if we think about x was our number of minutes. That's what we have set down here. So how many minutes do they charge for? Well, they say right here they only charge for the first 5 minutes. They don't charge for any minutes after that. So our domain would either be 0 minutes, 1 for 1 minute, 2, 3, 4, or 5. We don't know how many minutes you're on the phone call, but those are the possibilities. They don't charge after 5 minutes. And so our range is thinking, what happens when we plug these x's in? What kind of y values do we get out? So if we plug 0 in, if we plug 0 in for x, we get just 45 cents. So it would be a 45-cent phone call. Okay? That would be for 0. If we plug 1 in for x, it would be a 70 cents phone call. You can certainly check my math. If you plug 2 in for x, 0.25 times 2 is 0.5. 0.5 plus 0.45 is 0.95. And so on. And the rest of the ones that we get are 120, 145, and 190, 170. So domain is all of our possible x's, 1, 2, 3, 4, 5, 6. Range is all of our possible y's, 1, 2, 3, 4, 5, 6. So in this case, it wouldn't have made sense to use an x value that was bigger than 5 because they don't charge for more than 5 minutes. Also, it doesn't make sense to use a negative number. You're never going to call for a negative number of minutes. So we have to make sure that when we're picking these things, we're choosing a reasonable domain and range. So make sure that when you are done with this, I'm going to erase, so if you still need it, just pause the video. Alright, so make sure that now that you are done, you complete number 5 and 6, which you've already glued in your notebook. Number 5 and number 6 on the left-hand side. Right, thank you.